All right, let's try to finish this up. So we said the last thing we were going to do was a chord, and a chord does have something to do with a circle. Whoever's whistling, you need to stop. All right. So here's a nice little circle. We've already talked about a couple things, haven't we? We've talked about what? Remind me what we talked about. The radius of the circle. I think we only talked about two things, didn't we? The center of the circle, right. And so I'm going to draw a little center right there. There is the center of the circle. I'm not going to draw a radius just yet. We will talk about the radius in a little bit. But so that's the center of the circle. Let's draw a chord. Let's put that in a different color. So a chord does this. Well, let's go back to the radius, okay? What does the radius do? It starts where? At the center, and it goes anywhere, right? It goes anywhere on the circle. Would you agree? And that length would be the exact same, no matter where on the circle that you hit it, okay? Right there, that would be a radius. I could come to here, that would be a radius. What's true about both of those those little line segments? They're both the same. They have the equal length, don't they? They have equal length. So we know that already, but let's talk about a chord. So a chord, basically what it does, it connects 2 points on the circle. It's a line segment, has a starting point and an end point, and so it connects 2 points on the circle. So I don't know, let's start here and go to here. So what did I just draw? That's called a chord. Is a radius a chord? It's not. Why not? That's right. It only hits the circle at one side, right? Not two sides. Radius hits the center, but it only hits the circle in one point. A chord, let's jot that down. It's C-H-O-R-D. A chord hits the circle in two places, right there and right there. Everybody good? All right. Let's do another chord, a more specific type of chord. So this chord that I'm going to draw actually goes through the center of the circle. Does that mean it's a radius? No, because a chord has to hit both sides of the circle. Well, I shouldn't say both sides of the circle at 2 points, okay? So, I don't know, we can go through this one. It doesn't make any difference. As long as I draw my chord through the center of the circle, that's what I'm talking about right there. And you probably already know this word. You may not have heard the word chord before, but I bet you anything you've talked about this yellow one in past math classes. What'd you say, Tyler? What is it? What's the yellow one? I thought you told me what that yellow one's called. What is it? It's not the circumference. We're going to talk about that in a little bit. Diameter. It's the diameter. Okay, let's write that down right here. I'll keep it in yellow. Do you see a relationship between the diameter and the radius? Yeah. So what do you think that relationship is? Selena, did you say it? Oh, I thought you said something. What's the relationship between the diameter and the radius? Dom? Yeah, that's right. The radius is exactly half the diameter. Or you could say it the other way. How else could you say it? The diameter is 2 times or twice the radius. Either way, it means the same exact thing. Yeah. Okay, so let's write that down. So the diameter is equal to what? Twice the radius. All right? So if I drew a radius from that center to here and here, that diameter is exactly twice as much. If you wanted to, you could draw a radius from here to here. Okay? That yellow one, I know, is twice as big as the red one. Why? Because the red one is a radius, the yellow one is a diameter, and the diameter is always twice as big as the radius. Logan, I'm up here. Apparently you don't know, so I'm reminding you. Everybody understand that? So that's pretty important. We're going to talk about that in a little bit. Let's do this. let's put some letters in here. Let's do a chord. So when I ask you for a chord, the endpoints of this thing are AB. So what kind of a figure, I guess, what kind of a shape, I don't know, a good way to say it, is AB. What is AB? Is it a line? Is it a ray? Is it a line segment? Is it an arc? Is it what is it? It's a line segment. It's a line segment because it has two endpoints, correct? All right, so if I said name a chord, so number one said name a chord, what would you say? Okay, you just wouldn't put an AB. What would you put on there? The line segment over top of it. Because if you just put an AB, what does that mean? What is it? I can't hear you. The point? No. When you just put AB, it means the length of that line segment, okay? So I'm not talking about the length of the line segment. I'm just saying the name of that line segment is AB, or the name of that chord is line segment AB. It's probably a better way to say it, all right? Does that make sense? The All right, here we go. So the diameter is also a chord, isn't it? All right, so the diameter is a chord too. If I put some letters here, I'm not going to do that just for the sake of time. If I put some letters here, you could write down that that's a chord as well. Is the red one, is that a chord? No, it's a radius, but it's still a line segment though, isn't it? All right, so if I told you what the center of this was, if the center was like O, a lot of times they write the center as O, I don't know why, but sometimes they do, and we'll call this C. Then OC would be the radius, right? And it's not just OC, but it would be what? Line segment OC. That would be the radius. This chord, I don't know, call it DE. That's the diameter. This is just a regular old chord. And how many chords could I put on here, do you think? An infinite number of chords. Yeah, I could put an infinite number. And I could put an infinite number of diameters and an infinite number of radii. Oh, did I ever say that word yet? Oh, let's say that. So watch. So radius, you know what that is, right? But a radius is just one. You just have one radius. What if you have more than one radius? I already said it. It's called radii. Have you heard that word? Yep, two I's. So radii is plural. I'll put a PL after it for plural. All right, so if you have more than one radius, that would be radii. Okay, let's keep going. Oh, somebody said circumference earlier. What is the circumference? If I ask for the circumference, very good. It's the distance around the circle. Perfect. Couldn't have said it better myself. So if you start, let's say at D, you can start anywhere on here, but I'll just start at D. And if I can stay on here, it'd be a miracle. Whoops, a little wiggly. I'm getting there. I'm pretty, there we go. Not too bad. All right, so that's the circumference of the circle. Yeah, write out a pass. I'll sign it. So that would be the circumference of the circle, or the distance around the circle. I'm not doing that. Don't laugh. So the distance around the circle is called the circumference. That's pretty important. So we're going to learn two formulas. We got one more thing to do. See how that goes around like a curve? I'm going to get rid of it. What if I just went from D to B? Is that the circumference? No, the circumference is the whole way around, from one point all the way back to that point, okay? But this is kind of a curve. Is it a line segment? No. That blue one right there. It's not a line segment, okay? But we call it, I think I talked about it just briefly. I think I just mentioned it once. We call it an arc. An arc, all right? So when it goes around the circle, a portion of the circle, not the whole circle, because that's the circumference. But if it goes around a portion of the circle and it's an arc, all right? And we have a symbol for arc. So we would call this, just like a line segment, it doesn't matter. I could have called this line segment AB or BA, correct? So for a chord, what do you think we're going to call that chord? What is it? Chord what? This blue chord right there. DB, that's right, chord DB. Or not chord, I'm sorry, arc DB, arc DB. Or what else do you think you could call it? Arc BD, doesn't make any difference, okay? So the word arc, we have a symbol for it. So we're not going to write down the word arc, we write DB, and then you watch, you put a little arc right over top of it. And that thing right there means arc, okay? So that means it goes around the circle. It's not straight, okay? It doesn't go from one point straight across to the other. It follows the curve of the circle, okay? We don't call it a curve, but we call it an arc. So there's a whole bunch of arcs in here, right? You could have arc DA, arc AC, arc CA, or CE, arc EB, but then you could go arc what? Arc DE, couldn't you? Okay, and arc DC, right? You can combine a bunch of those arcs. We're not going to, I don't think, let me just double check. I don't think we're going to get really into that right now. We are not. But later on, we will get more into it. We got a thing called a major arc, a minor arc. Diameter is, if you go from here all the way to C, you're going halfway around the circle. You probably heard this word before. What do you think it means to go halfway around the circle? It's not a whole circle, it's a semicircle, that's right. We're going to learn that later, but that's stuff that we're going to talk about some other time. We're just hitting this really quick just to kind of get a little bit of knowledge about circles. Not a ton. One thing I really want to do, though, is use this diameter as twice the radius kind of thing. So we talked about circumference, didn't we, when it goes all the way around the circle? We actually have a little formula. Let me grab this, make it white. We have a little formula for the circumference of the circle. Now, what letter do you think that we use to represent circumference? Pretty easy, C, right. No, we use F. No, we use C for circumference, makes sense. All right, so the circumference is equal to, now, we're going to introduce you to something here. Let's take a look at this. I'm going to try my best to do this. It might not be super accurate, but it'll be close enough. We'll try. So if I took that diameter, okay, and let's say it was a string, right? So I did it tight, it's a nice straight line, right? But then I let one end go and it's all floppy. Everybody got that? Okay, so I got a string and it's the length of that diameter. And if I was to wrap it around the curve of the circle, everybody hear me? Okay, see what I'm saying? A lot of times, I haven't done this the last couple of years because I always forget, but I used to have a cardboard circle that I cut out and I had string and I would do this, but I don't have it right now and I'm not going to take the time to do it right now. Maybe another day I will. But if I took that diameter and wrapped it around, right, do you think that whole diameter would go all the way around the circle? How many of those diameters, that yellow one, how many of those diameters, if you could wrap it around the circle, do you think it would take to go all the way around the circle? 2 of them, 3 of them, 4 of them? It's really close to 3. It's just very good. It's a little bit more than 3. Just a little bit more than 3. What number do we know that's just a little bit more than 3? 3.14, which is pi. Very good. So if I took this, watch. Again, this is not going to be very accurate. I'm just doing this by hand, so give me a little break here, okay? So if I took that yellow one, let's tell you what, let's make it yellow. There we go. Let's make it yellow. And so, I don't know. We'll see. So when do you think that's one diameter? Maybe about like that? A little bit more? Okay. Let's change colors and we'll just see the difference between the diameters. All right. And then we got another one. Again, I'm just eyeballing this. I want to get the same, about like that maybe? Yeah. Pretty close? Okay. What color do you want now? Blue? And then we're going to go all the way to, is it going to go all the way to D? Yeah. It's going to stop a little bit short. Okay. And then what haven't we used yet? Green? Oops, see daisy. There we go. And then watch this, just a little bit more. So the relationship between the circumference and the diameter, the circumference is equal to how many diameters? 3.14. Or we're just going to say what? You guys said it. Pi diameters. So that's our formula. Pi diameters. Again, this is something else that I probably should have had prepared, and I just think of it when I am doing this. But there's actually several Bible verses that refer to pi. They don't use 3.14, okay, but they do say there's, and I learned this in college, and then I looked it up on Google. You could look it up yourself, not right now, but some other time you could look it up. Does the Bible refer to pi? Is pi referred to in the Bible? And there's several times when it talks about, maybe like this one verse I'm talking about, it's talking about a lake, like a circular lake, and it says something, I don't know exactly what it says, but I have read it, and it says something about the distance around the lake is 3 times as far as it is across the lake. All right, and so what's across the lake? That's the diameter, right? What's the distance around the lake if it was a circular lake? Okay, that would be the circumference. So it does kind of hint at, it doesn't say specifically 3.14, but it does hint that it's around 3 times the diameter, right? The distance around a circle is about 3 times the diameter. And I've heard people say, well, that proves that the Bible's wrong because it's not 3 times the diameter. It's 3.14 times the diameter. It's like, come on, this is thousands of years ago, right, that they came up with this, and they're not going to put in the Bible 3.14. I don't even know if they had decimals thousands of years ago. I mean, they did a lot of math. They did a lot of geometry back then, in Jesus' day, in the Old Testament even, that kind of stuff to build things. But, anyway, there you go. So there's 1 diameter, 2 diameters, 3 diameters, and just a little bit, there's your 0.14, all right? So there is your formula. The circumference is equal to pi times the diameter. Here's another way that we see circumference written. Remember this? What's the diameter? The diameter is twice the radius. So instead of putting d, what do you think we could put? Pi times what? 2r, twice the radius. Isn't the diameter twice the radius? Yeah, so I could put that in there. Now, we rearrange it just to make it look a little bit nicer. A lot of times we'll put the number out in front. So let's do that. So put the 2 first, then the pi, then the r. So right here, these are 2 different ways. Whoops. Let's use this thing. This is 2 different ways where you could describe the circumference. All right, you could go pi times the diameter, or you could go 2 pi r. A lot of times we kind of fall back on that 2 pi r, because in a lot of questions they'll say, all right, here's the radius, what's the circumference? So if you just remember 2 pi r, then you can find the circumference pretty easy. Sometimes they'll give you the circumference and you got to find the radius. Can you do that? You're going to have to do a little bit of algebra with that. What if they gave you the circumference? I'm just making up a number. Let's say it's 10, all right? How would you find the radius? I'll put a question mark here. Well, here's our formula, right? So what are you going to put in for the c? 10 equals what? 2 pi r. Now, you only got one variable now, don't you? So how do I get r by itself? I have to divide by 2 pi, correct? So you divide this by what? 2 pi. The 2's cancel, the pi's cancel, and that's what the radius is. It's 10 over 2 pi. You could always put that in a calculator if you wanted to, figure out what it was, but that's how you can find the radius if they gave the circumference. Make sense? All right, so that's kind of cool. All right, enough of that. Let's do a couple examples, 3 examples actually, and we'll be finished. Right a pass. All right, so this is officially example 5 in the book. So if you look at example 5, you'll see this in here. It's just A and B, so there's only 2. I thought there was 3. There's only 2. I don't even think we need to draw a picture of the circle, so I'm not going to. let's just do this. So they tell you, you have a circle, and they tell you that the radius of that circle is 10 centimeters. So part A says, I think, hold on. Oh, the circumference. What am I doing? There's a C right in front of my head, and I wrote R. That's kind of silly, isn't it? So it's not the radius is 10 centimeters. Because I looked at the problem, they're saying find the radius. I'm like, well, the radius is already there. So they don't tell you the radius. That's the same exact problem that I just did. I just made that number up too. It's the same exact problem as what I did right there. So that's actually part A. They tell you the circumference and you got to find the radius. Look at that. I've been teaching this so long, I knew exactly what they were going to do before I even looked at it. So that's part A. That's example 5, part A. I've already done it. That's kind of nice. So let's make this B now. Oops. This was part A, the thing I did with the 10. That was part A. All right. But I didn't realize when I was doing that, I just made up a number. I said, let's just make up 10. And then after I did it, I looked at my example, and that's the same exact number that they used in the example. Everybody understand? Okay. Yeah, Cameron.
You can simplify 10 over 2 pi to
5 over pi, correct. You could. Okay, because the 2 goes into the 10. So you could just make it 5 over pi. And there's a lot of times, especially when you get a little higher up in your math, that they don't care that you put 3.14 in. They just want to see the pi. And a lot of times, not all the time, but sometimes, you can keep pi in your answer and they're fine with that. All right. My guess is for a high school geometry book, they'll probably want you to put 3.14 in there. Now, if you get your calculator out and you probably see a pi button on your calculator, now that'll take it out a whole bunch of places. I don't know, like 8 places or something, depending on your calculator. But don't use the pi button on the calculator. Just use what? Actually, I shouldn't put equals. Yeah. Just use 3.14. So anytime you're going to do something with pi and you're going to put it into a calculator, use 3.14. Don't use the whole 8 digits, because really there's, in reality, there's nothing that we have, unless it's some super fancy scientific lab or something like that, that can measure stuff that accurately to 8 decimal places. I mean, it's crazy accurate. But nothing that we make, we can measure that accurately anyway. All right, so let's just use 3.14 to the 10th place, or to the 100th place is good enough for us. All right, let's do the last one and we'll be finished. This time it says find the circumference. I'll just put C. It says of a water tower, okay? You ever see these water towers? They go up, this big old globe kind of looking thing, right? And there's water in there. So we want to find the circumference that measures 60 feet across. So it measures 60 feet across. What are they telling you right there? They're telling you the diameter, aren't they? All right, so let's put D equals 60 feet. Everybody understand that? So if it's across, right, from one end to the other, that's the diameter. So they tell you this thing is 60 feet across, and it's circular, right, because these water towers, for the most part, they look circular, don't they? Yeah. There's actually a reason why they make them circular. You can look that up. But so we want to find the circumference. Now, am I going to go 2 pi r? I mean, you could, right? Figure out what the radius is. What's the radius of this? It's the radius. It's 30, right? But then you got to multiply by 2 anyway, and you're back to the 60, right? So you could just remember that the circumference is also equal to what? Pi times the diameter, correct? If you remember them both, if they give you radius, then use 2 pi r. If they give you the diameter, use pi times diameter. All right? Everybody good with that? And so what is it? It's just pi times what? What's the diameter? 60. But how do we write it real nice? We'll write it 60 pi. And you could probably just keep it like that. My guess is you could keep it like that. I don't really know what this book does. I can't remember. But I know I've taught out of other books, and they were perfectly fine with you keeping it 60 pi. All right? But if not, what are you going to do? You're going to go to your calculator. You're going to hit 60 times what? 3.14. Get whatever you get, and then that would be your answer. I would be perfectly fine with that. If you just wrote 60 pi, I'm good with that. All right? If you look in the back of the book, if it's an odd problem, they might write it as a decimal. And the more I think about it, they probably do, which is fine. We good? Yeah, easy stuff, right? Not too hard. This is just all introductory stuff, all right? Because we're just hitting little things that we're going to really expand later on. We're going to go into way more detail. Like I said, with the circle stuff, well, with the circumference and radius and all that, there's a whole chapter on doing area and perimeter, right, is what this is. Isn't circumference just the perimeter, right? The distance around something is the perimeter. So we're just hitting little tiny bits just so you can kind of see what's going to be ahead. All right, let me give you, what was your homework last night? What did I give you there? 13 to 20, 30, or 31 to 43? Yeah. Okay, so we're going to continue. I'll tell you what, let's write it down here. I usually write it in red, so let me write it in red. So tonight you are doing section 1.6, but this is part B. I know what you're thinking. I thought, Mr. Hamrick, you taught 1.6c today, but why do I put part B on the homework? It's only the second homework, right? Yeah, so that's why I put part B. I know some people get confused with that, but that's how that goes. All right, so it's page 37, and you are doing 44 to 53. 44? Yep, because last night's homework was to 43, correct? So today is 44 to 53. So that is your homework. Okay? Remember, you have a quiz tomorrow.
Can we put it on the same paper?
No. I'm going to collect 1.6a in a minute or two, okay? Because we're going to go over that. And then, so these are two different assignments. So do them two different papers.